We always hear about climate change in these huge, kind of abstract ways, right? Melting ice caps, sea levels on the rise. But what does it actually mean for, say, a single animal just trying to live its life? Well, that's what we're going to do today. We're going to take a really cool scientific study and turn it into a story about what a warmer world really feels like for one small, sun-loving lizard.
So it all boils down to this, really. Will lizards actually survive in a warmer world? I mean, they're cold-blooded, right? So your first thought might be, probably not. But, and this is a big but, the real answer is so much more complicated. And honestly, it's way more surprising than you'd think. Okay, so to dig into this mystery, we need a main character. And here it is. Meet the prairie lizard. This little guy lives all over the central United States, and today, it's going to be our guide. We're basically trying to solve the puzzle of its future.
All right, so the simple, kind of obvious assumption goes something like this. Lizards are ectotherms. All that means is they're basically solar-powered. They need the environment to warm up or cool down. So if it gets too hot, they're in trouble. Too cold, they can't move. It makes perfect sense that a hotter planet is just bad news for them. But here's the thing, that's just one piece of a much, much bigger puzzle.
So, our first big clue in this whole investigation isn't just about how much warmer it gets, it's about the rhythm of the heat. Think of it less like a steady climb and more like a daily temperature roller coaster.
Okay, let's think about how these studies usually work. In a lab, to keep things simple, a scientist might just stick a lizard in a tank at a constant warm temperature. But when's the last time you experienced a day like that? Never, right? A real lizard's life is this constant cycle of cool nights, warm days, finding a sunny spot, then ducking into the shade. It's always changing.
This is where the researchers got really clever. They set up two different 24-hour temperature patterns. The first one basically mimics a normal day. Things are cool at night and then they warm up in the afternoon. But the second one, they flipped it. They made the nights warm and the days cooler. The big question was, would the lizards even care? Would their bodies notice the difference in the pattern?
And wow, did they notice? The results were pretty wild. A flat, steady temperature in a lab, that gives you one answer. A realistic daily cycle, you get a totally different answer. And just flipping the pattern to have warm nights, that changed everything again. The takeaway here is huge. The rhythm of the day, that roller coaster, is just as critical as the average temperature.
But hold on. Even with all this new info about temperature cycles, we're still not seeing the full picture. Because every good mystery needs a plot twist, right? Well, in our lizard story, that plot twist is all about food.
So, the scientists didn't just play with the thermostat. They also messed with the menu. They set up 3 temperature scenarios. What we have now, a world that's 2 degrees warmer, and one that's 4 degrees warmer. And for each of those, they created 3 food levels, low, medium, and high. That gives us 9 totally different worlds to test our lizards in.
Okay, so this is where it gets super interesting. You've got these 2 big factors, temperature and food, both changing at the same time. So how do they actually interact? Do they cancel each other out? Does one matter more than the other? Let's find out.
And this is where your brain might do a little flip. Get this, when there wasn't much food around, the lizards with warmer nights actually ate more. Yeah, you heard that right. More. But when there was plenty of food, the warm nights didn't really change their eating habits at all. I mean, that just completely messes with the simple idea that heat is always bad, doesn't it?
So here's the absolute key point. You just can't look at temperature by itself. Its effect completely changes depending on how much food is available. It's like they're locked in this complicated dance, and the steps of that dance are what will decide if the lizard makes it or not.
All right, so how does this all work? What's the connection between temperature and food? Well, to figure that out, we have to think a little like an accountant. We're going to look at the lizard's energy budget. Basically, it all comes down to income versus expenses. Okay, there's a sciencey term for this. Metabolizable energy. It sounds super complicated, but it's not, I promise. Just think about your paycheck. There's your gross pay, and then there's what you actually take home after taxes. This is the lizard's take-home pay, the energy it actually gets to use after its body is done processing the food. And this energy budget is pretty simple. It's got 3 steps. Step 1, income. That's the energy from food. Step 2, paying the bills. You know, the energy it needs just to keep the lights on, to breathe, to move. And step 3, and this is the most important one, whatever is left over. That's the profit. That's the extra cash it can invest in its future, things like getting bigger, or most importantly, having babies.
And that leftover energy, that profit, it's literally everything. Having a positive energy budget, more coming in than going out, is the only way an animal can grow and have offspring. If you scale that up, it's the only way an entire species survives. No profit means no future. It's that simple.
Okay, let's recap the investigation. We know the rhythm of the heat matters. We know that it tangles with food supply. And we know it all comes down to an energy budget. So now it's time to connect the dots and see the final verdict. What does this all mean for the future of these lizards?
Whoa, okay, so this chart shows us the number of eggs a female lizard is predicted to lay. Don't worry about all the lines, just look at the colored dots. The blue dots up top, that's when there's plenty of food. And look what happens. As it gets warmer, they actually lay more eggs. But now, look at the red dots way down at the bottom. That's when food is scarce. As it gets warmer, the number of eggs they can lay just completely tanks. It's a total collapse.
So the number of eggs is a direct result of that energy profit, right? That makes sense. But what happens when you zoom out? What does this mean for the entire population over, say, the next 50 years?
To answer that, the researchers ran a simulation to see what the future might look like. And the results are, well, they're two completely different stories. In a world with lots of food, the population does great. It grows. But in a world with not enough food, at the exact same temperature, the population just plummets.
Let's put a number on it. Scientists have this thing called lambda to measure population growth. Super simple rule. If it's bigger than 1, the population is growing. If it's less than 1, it's shrinking. So, with lots of food, the lambda is 1.09. That's a success story. The population is healthy, it's growing, it's thriving.
But in the world where food is scarce, the story is a total nightmare. The lambda is 0.38. That's not just shrinking, that's a freefall. At a rate like that, the local population going extinct isn't a maybe. It's pretty much a mathematical guarantee.
And that, right there, is the final verdict of our whole investigation. The exact same temperature can lead to a population that thrives or a population that vanishes. The single factor that flips the switch between life and death, it's not the heat, it's the food.
So that brings us to the big takeaway here. The simple story we always hear, it's getting warmer, is just not enough. It's dangerously simple. What this one little lizard shows us is that the reality of climate change is this incredibly complex web. And that leaves us with a really important question to think about. If all we're ever looking at is the thermometer, how much of the real story are we missing?